Have you seen a wheel that is pure rolling on a ground? Surely you have. Perhaps you don't know that this pure rolling is not just limited to circles. For example, we can have a parabola or ellipse that is pure rolling on the ground. Are you eager to know how I created these animations? Well, keep watching this video as I reveal the secret. Also, at the end, I will solve one of the so-called toughest problems of conic sections. Before I explain what is pure rolling, let me give a formal definition of sharp corner. While it is pretty intuitive that this point A, this point B, and this point C are sharp corners, still let me say what it means in a formal manner. In a formal manner, I mean to say that if this body is rotated by some angle, by some small angle delta theta, if this body is rotated by some small angle delta theta, then a point on the body must again be in contact with the surface. See, with this surface, initially point A was in contact, but if I rotate this body by say some small angle delta theta, you see that except point A, other point cannot remain in contact because the neighboring point of A is not at a small angle delta theta, it is at a significant angle. See, this angle is say according to this diagram 45 degree for example. So this is not a small angle. So the neighboring point of A cannot be in contact if the object is rotated by a small angle delta theta. Hence we say that A is a sharp corner. So I hope it makes sense that what I mean by sharp corner. So if a body is say like this, here when I touch this body on this ground, this is point A. Let me touch it. See, it is touching the surface. Now if I rotate this body by some angle delta theta, well, it can be something like this, you can imagine. So if I rotate it by some angle delta theta, you can see that the point neighboring to A will remain in contact. Or you might say that it will be the point in this direction, whatever, but there is a point in the neighborhood of A that will be in contact if the object is rotated by delta theta. So this is what is the sense of pure rolling. Unless we can find such a corner, it does not make any sense to define pure rolling. So I am talking of a body that does not have any sharp corner, because only then pure rolling is possible. Now let me formally begin with what I mean by pure rolling. So we all know that for pure rolling, if this is the point of contact A and this is the surface S, then the velocity of this surface and the velocity of this point of contact must be same. So V1 must be equal to V2. But this is not that much intuitive, or I must say that this does not give that feel that is required to solve this question. You must have a more clarity in what I exactly mean. So to give a more to give a definition that provides more feel, let me say that this is the object. This is the object. Let me paint its outer surface with red color. I hope you are following me. I am painting the outer surface of this body with red color, and I am freshly painting it. Right, it is a fresh paint. Means if I touch it with my hand, the paint will come in my hand. So I'm painting it with red color, and I'm painting the surface, or let me paint it with gray color to make it see on the screen, but essentially think that I'm painting it with white color. Just to be visible on the screen, I am painting it with gray, but think that I am painting it with white color. Now I am freshly painting the object and the surface on which the pure rolling is supposed to happen. So at this point of contact A, what will be the color observed? Obviously I cannot show it in my screen whiteboard, because here the layers are being superimposed, means here one layer is kept over another, the colors are not essentially mixing, but in real life the colors mix. I'm telling that it is freshly painted, so colors will definitely mix, and at the point of contact A the color will be pink, right? Because it is red plus white, it will give the color pink. Now, let me define what you all know have heard of translation and rotation, or rather pure translation and pure rotation. So, what does it mean? See, if the object is said to be in pure translation, it essentially means that when this object moves in this direction, it does not rotate. What I mean is that if the object comes after time, sorry, I drew it wrong. So the shape. So this is the shape of the object. At t equal to 0, it is here, and at t equal to t, it is here. So if it has moved like this, only the point of contact A will have pink color, and rest all the object part of the object will be red in color because it has not rotated at all. Since it has not rotated, so rest all will have pink color, and only the point of contact A will have will have red color. Sorry, I said it wrong. I apologize. The object will have red color except at the point of contact A, and the surface on which it has moved, this will gain pink color because the red ink is constantly being coming here. So this one will gain pink color. So this is what I mean by pure translation. And what I mean by pure rotation. So what I mean by pure rotation is that if the object is not moving from its place, say this is point A, the ground was initially colored white. Now only the point of contact A is colored pink and the object is not moving from its position. So what will essentially happen is that some part of the object will turn pink in color and the remaining part will be red, and if it rotates full turn, then the whole object will turn pink in color, but the ground will remain unaffected, the surface will remain unaffected, the surface everywhere will be white except at the point of contact A. So this is what I mean by pure rotation. Now what is pure rolling? Now let me come into what is pure rolling. So pure rolling is said to happen if, say, this is the surface, at t equal to 0 it is here, and at t equal to t, the surface need not be a straight line, it may be any curve also. So if at t equal to t it is here, so the surface was initially colored white. Initially it was colored white. After it has traveled at time t equal to t, this part will be pink in color, and since the object has also rotated, a part on its perimeter or circumference will also be pink in color. And if it has not rotated full turn, so the remaining part will be red in color. Right, here the full object was red in color. So the point is that the amount of pink color, the perimeter of pink color must be equal to the perimeter in both the cases. So you see, if this distance is d, then this distance must also be d. So both the distance must be the same. So this is the actual meaning of pure rolling. That is, the two lengths must be same. This is measured along the surface. This is not necessarily a straight line. So these two distances must be same. You can feel it like that. See, if it is slipping at some point of time, that is, at some point of time it is slipping means it moves forward without rotating. If it happens in some case that the object is moving forward by a small distance without rotating, then you can see that it will not, see, after time t, if it comes here, so this part will not turn pink because it has not rotated, but the surface on the ground will turn pink because it has translated, so the distance will be unequal. Also, if it does not translate but rotates at one point for some time, so the objects, this surface will turn pink, this surface will turn pink, but the road or the ground will not turn pink because it has not moved at all. So in both cases is not allowed. It has to, it cannot slip. I mean to say that it cannot slip. So the distances must be same. This d1 and d2 must be equal. So if I call this, say, d1 and d2, so I must have d1 equal to d2. So this is the most useful result that I will be using to solve the questions or to create the animation that I showed. And one more thing that is required is that, say, I drew a random shape, it may not be a parabola, it can be any shape. Suppose it is rolling. So after some time, it the shape will be something like this. Sorry. the axis can be here and it is rotated by some angle. So after some time at t equal to 0 it is here, and at time t equal to t it is here. So what is this actually? We can have a different perspective to look at this. Consider this shape and imagine that the surface, or here this straight line, that is the tangent, is rotating. At time t equal to 0 it was here, and at time t equal to t the tangent was here. Right, at time t equal to t the tangent was here. Now look from this angle. Change your perspective, rotate the screen of your device and look from this angle. And when you look from this angle, this picture and this picture are exactly the same. That is, I rotate the surface or I rotate the body, it makes no difference. That is, the both are completely the same. These are invariant. So I can rotate the surface or I can rotate the object. So for my convenience, I will be rotating the surface or the ground, that is tangent, and that will help me a lot in solving the question. So as rotations are involved, so you have to know a little bit about transformation of axis. That is, if this axis is shifted, translated by some distance, the new origin is x naught comma y naught. So what will be the equation and how to transform that axis? This one you must know. And the most essential thing that you must know is rotation of axis. So if this is rotated by some angle theta, then how are the coordinates of the points related? That is, how is x comma y related? So that things you must know. That is, the x comma y in the new coordinate system, how to find out that you must know. One trick is there that I think you know this, but still if you do not know, let me tell just for the purpose of this video. You must have learned this in the coordinate systems chapter. Still, if you have not learned, I am telling you, just remember the result, I am not deriving it. You know that in complex numbers, if there is a complex number z, if I multiply it by, if I want to rotate it by theta, I multiply it by e to the power I theta. So e to the power I theta is a thing is used to rotate something, right? So the analog of e to the power I theta is this matrix. If we do not involve complex numbers, if we solve in simple coordinates only, then we can use this matrix to rotate a point x comma y. So this matrix is used to rotate a point x comma y by some angle theta in anti-clockwise direction, cos theta sin theta minus sin theta cos theta. You can remember it like this, that in physics the unit vector r, is written like this, and if you take the derivative, the unit vector theta cap is written like this. So these things you must know, that how we are rotating the axis, and once we know this, we can dive into how I created the animation. Consider a curve f of x comma y equal to 0. So this is my y-axis and this is the x-axis. Consider a curve. As I have explained previously, to make it roll, we can consider that at a point, say a, x1 comma y1, we have to draw the tangent and we have to see this perspective. We have to look it from this side, and if this distance is L, then we have to place it at a distance L on this surface. Here I am considering that it is rolling on a straight line. It may not be the case, but still I am assuming for this problem. So this distance must be L, it must be kept at this side, and the image that is seen with respect to this tangent, according to that the curve must be drawn. First let me tell how we can take the perspective of with respect to that tangent. If this point is A, x1 comma y1, so in GeoGebra there is a option to find slope of a tangent with respect to this curve. We can input the equation of this curve and they give us the slope at this point A. So once we know the slope, what we can do is, see, we can transform this axis and find a new axis. So according to that new axis, what we will get, it is x minus x1 and y minus y1. If the new axis, with write it as capital X and capital Y, where this is the center of that new axis, point A, and I have to rotate it by angle theta, this theta, cos theta sine theta minus sine theta cos theta. So I will get what how I will rotate it. So let me tell what will be the image if this is capital X and this is capital Y. So this function will give me f of capital X comma capital Y equal to 0. Sorry, I drew the diagram wrong. It will be not that symmetrical. I hope you can feel it, that it will be tangent at this point and somewhat like this. So this will be the figure that I will get. Now what I need to do, I need to shift it by a distance L. I need to shift it by a distance L. So for that, what I have to do, I have to replace this X with X minus L. Once I replace this X with X minus L, it will be shifted by a distance L. And the final thing, how to calculate L. Calculating perimeter takes much more time than calculating area. Calculating area is very simple by doing integration, but calculating area involves integration, but calculating perimeter involves sufficiently lot of time from computer's perspective. So if this distance is dx and the slope at this point is theta, tan theta, the slope of the angle that it makes with x-axis is theta. So what is this dl? dl equal to dx sec theta. And what is the value of sec theta? Root over 1 plus tan square theta. And tan square theta, I am writing tan theta I am writing as m, the slope. So root over 1 plus m square. This is dl, and we need to sum, or rather I should integrate. But I will say that for this question I will do a summation for all possible dx. And using that I will calculate the perimeter, and after that I will shift. So what is my final expression looking like? X minus x1 is equal to, if I multiply this matrix, x minus L into cos theta minus y sin theta, right, and y minus y1 equal to x minus L sin theta plus y cos theta. So the transformed equation of the curve will be x1 plus x minus L cos theta minus y sin theta, comma y1 plus x minus L sin theta plus y cos theta equal to 0. So this will be the transformed equation. So as I have this, now let me show it in GeoGebra how I did it. So I have opened GeoGebra, and in equation 1 you can see that I have written the see, as you can see here. Wait, let me change the color for one time. Yes, so here I have written the original equation of the ellipse, and I can take the slope at any point A. I can find the theta, and see I have written the function to calculate the perimeter. What I used to call as L, that is here written as P. That is the length traveled along this direction. So I have basically done the summation. Here I have taken this distance as dx. So this is very small with respect to our units. We are all dealing with, say, 0.1. The distances differ. The least count is 0.1, but here I have taken a unit very small, 0.001. So it can be treated as dx. And I have taken a sum. See, I have given the summation function. And as I have told, the same formula I have written here. And after that, see, I have replaced x with this term, and I am showing that I have replaced y also here. See here, I have replaced y also. And after replacing y, I have put that in the original equation. And after that we get the required animation. So as you slide A, see I am sliding A, and this curve is also rolling. So similarly you can put the equation of the parabola here, and you can see that the parabola will also roll like this. Now let me come to that tough question which I told you. So this question is no longer tough because I have already told the concepts that are involved. The question is, the bottom parabola is fixed while the top parabola purely rolls, or rolls without slipping. over this fixed parabola, we need to find the locus of the focus of this parabola. Consider a point P in this moving parabola. When does it touch this fixed parabola? So if this distance is L, it will touch at the same distance L, and since these two parabola are identical in shape, so the point Q must be the mirror image of point P. If I write the parametric equation of point P, 2at, so 6t, 3t square. So the point Q will be 6t, minus 3t square. Right. And the tangent drawn to the fixed parabola at the point Q. At this point of tangency, this parabola must be there. So the moving parabola must be tangent at this point Q. So if it is tangent at this point Q, what will be the focus, or where exactly will be the focus of this parabola? You can see that by symmetry, this parabola at this point will be the mirror image of the fixed parabola. So what will be the position of the fixed parabola's focus? We have to take exactly the mirror image. So let me tell what is the position of the focus of this parabola. 0, minus 3, minus a, so 4 3s are 12, so 0, minus 3, and we have to find the equation of this tangent, and we have to take the mirror image. So let me write the equation: x into x1 6t equal to minus 6 2y, y minus 3t square. So the equation is xt equal to 3t square minus y, or xt plus y minus 3t square equal to 0. And we need to find the position or the locus. Let us call it h, k, and by the property of reflection, h minus 0 by t equal to k plus 3 by 1 equal to minus 2 into, I need to put this point, so 0 minus 3 minus 3t square divided by 1 plus t square. So what does this equal to? 3 to the 6. So I am getting that k equal to 3 or y equal to 3 is the required locus of the focus. So that is the required answer.